Hey everyone, we're going to look at number 8 here in section 9.1. We're going to solve the initial value problem given here. All right, we have the differential equation. Notice it is with respect to t, so we're looking for y as a function of t. And here's our initial condition, which again is saying, when t is 1, the value of y is 0. So first of all, I'm going to multiply by dt. And I'm going to divide by e to the negative 3y, which is the same thing as multiplying by e to the 3y, right? And so when I multiply by e to the 3y and multiply by dt, I get to here. And we have indeed broken up this into two sides. One has y's only, the other side has t only. All right, so we have a separable differential equation here, which can be written as a function of t only times a function of y only, and we can always get to this form here in that case. Now, I integrate both sides. Now be careful here, the antiderivative of e to the 3y is not e to the 3y. Where did this 1/3 come from? Now there's a little substitution going on, right? If I let u be 3y, then du is 3 dy, and we have 1/3 du equals dy. That's where that 1/3 comes on. So again, we're just undoing the chain rule if I take the derivative of this. The antiderivative of 8t is 4t squared. Hopefully that's easy to see by the power rule. And then I'm going to add my constant, remember, here on the right. Again, it's the constant over here on the left minus the one on the right gives me this constant. Okay, so now what do we want to do? We want to solve explicitly for y, and then we'll apply the initial condition. So to solve for y, I'm first going to multiply by 3 on both sides. 3 times 4 is 12t squared. 3 times c, well, it's just another constant. Again, this, I'm going to just still write it c again. These c's are not the same. This c down here is 3 times this one, but it's still a constant. Now, how do we solve for y? Well, it's in exponential form. We need to write it in logarithmic form. So if we take the natural log of both sides, over here I'll get 3y. Over here I'll get the natural log of 12t squared plus c. Last thing to solve for y is to divide by 3 or multiply by 1/3. And so here's my general solution. Notice the c is inside the logarithm, right? If you have to add your c immediately. If you wait and then do this and then the plus c out here, that's incorrect, right? You have to include the integration constant up here and then follow that constant through your solving for y process. And a lot of times it ends up somewhere a little bit different than just, plus c at the very end of everything. So now let's apply that initial condition. Y of 1 is 0. Remember, that means t is 1. So I let t be 1. 1 squared is 1. I get 12 plus c in the parentheses. Of course, y is going to be 0. And so therefore, I know that this expression has to be 0. How do I solve for that? Well, I just put it in exponential form, right? Logarithms are exponents. So the log of 12t plus c being 0 means the exponent on e is 0 to get 12 plus c. Or if you just exponentiate both sides, e to the 0 is 1, and I get c is negative 11. So replacing c with negative 11 plus a negative number is just minus 11, and there is our particular solution. Again, your differential equation should be very similar to this, maybe a slightly different initial condition. Okay, hope this one was helpful. Really fun one here.